Now let's talk about cylinders. And cylinders are just like prisms, except they have circular bases. So we're still going to do volume equals base times height, area of the base. H is the height of the solid, the distance between the bases. But now, since a circle is the base, we're going to use pi r squared for b, uppercase B, the area of the base. So to find the jumped the gun there. Sorry about that. But to find the volume of the cylinder, we're going to start off by finding the area of the base, which would be pi r squared, so 16 pi. The height would be 7. All right, even though this is an oblique prism, we're going to use the perpendicular distance between the bases as the height. So the volume is going to be 7 times 16 pi. So when you multiply that together, 7 and 16, you get 112. So the volume is 112 pi cubic centimeters. That would be in terms of pi. So that would be the exact volume. If you wanted to approximate that, you can multiply 112 by pi, and you'd get the volume is around 351.7 cubic units. So now let's talk about pyramids and cones. Cones are to pyramids as cylinders are to prisms. They have a lot in common. And if you look at the formulas of volumes of prisms and cones, you'll see they have something in common. And same thing, just like the prism cylinders did. Now there's a YouTube link right there. I'm going to have you watch it if this is virtual learning. If this is class or whatever, you could always open up the notes and click on that link. But pretty much in that video, someone takes a prism and a pyramid that have the same exact base and the same exact height, and they fill up the pyramid with water. All right. So how many times do you think they would have to pour the pyramid's water into the prism that has the same base area and the same height in order to fill it up? So if you want to imagine that and take a guess, if you haven't seen the video yet, think about that now. Pause the video if you need more time. And the answer is 3. And I would open up this video and show you, but due to copyright reasons, I cannot do that. No, it actually just wouldn't come out that. It would be really blurry. But I encourage you to watch the video. So this is another kind of visual of that. If you had a prism and a pyramid that had the same exact height and the same exact base, and you filled up the pyramid with sand or water or whatever, you would completely fill the pyramid up, and you would have to pour it into the prism 3 times in order to completely fill up the prism. So that's why the volume of pyramids and cones are just 1/3 the area of the base times the height, because the base times the height is the area of the prism, and the pyramid and the cone are 1/3 of that. So B is the area of the base, H is the height of the solid. Whether it's oblique pyramid or straight, you're going to use the perpendicular height for H. Same thing with cones. Cones can also be oblique like that. So if it doesn't look like a normal cone, just find the distance from the top of the cone straight down perpendicular to the base. So let's find the volume of this cone. So we're going to do pi r squared, that's going to be the area of the base, times the height, which we don't know yet because 8 looks like it's the slant height and 5 is the radius. So those two form a right triangle with this height right here. So we get h squared plus 5 squared is equal to 8 squared. Do the Pythagorean theorem, and we get that the height is equal, I gotta subtract there, that's subtraction. We'll get that, and that should be gone too because we took the square root. The height should be the square root of 39. So we're going to multiply that in there, and since it's a cone, we have to divide by 3. So if we were writing this exact, it would be 25 root 39 pi over 3 cubic meters as the volume. If you wanted to approximate that as a decimal, you would type this into a calculator and get 52.04 cubic meters. Okay, last problem here. We got a pyramid with a hexagonal base. So we're going to, gave that away again. But now we're going to find the area of the base by dividing the hexagon into triangles. Okay, you could divide it into 6 congruent triangles where each of these angles would be 60. So when you split it in half, you get 30 and 30, 6 and 6, and then the height is 6 root 3. So you get base times height divided by 2 times 6 triangles, and you get 216 root 3 for the volume, for the area of the base. Okay. So now for volume, we're going to take 216 root 3, multiply it by the height, which is 20, and divide by 3. And you get 1440 root 3 cubic centimeters as the volume of this pyramid. And if you wanted that as a decimal, then you just multiply 1440 by root 3, and you get it to around 2,494.1 cubic centimeters. And that's it for volume. Next video will be on spheres, so I guess that's not really on the volume, but that's the end of this video series. Thanks for watching.